Okay, so like I said, I'm Mike. We have Vamsi here. So we're specifically part of the platform SRE team within Asset Wealth Management and also run observability for AWM. And just to be clear, this is not AWM strategy. This isn't JP Morgan strategy. This is just us as technologists, engineers thinking about how to think differently about open source technologies. How do we apply them in the finance industry? So why are we here? About 8 to 10 years ago, maybe some companies are more advanced and have started thinking about DevOps before 8 to 10 years ago, but we started thinking about how to apply DevOps in our organizations. And you think about how do you iterate more quickly, how do you improve your velocity and merge your development and operations teams together to act more effectively. And one of the things that you need in order to do that is effective monitoring solutions. And that became really apparent, especially 8 to 10 years ago. You needed to implement monitoring observability across all your different tech stacks, all your different infrastructure platforms, and those were all different tools. There were a lot of challenges with that. And as we move towards more focus on SRE in the more recent years, monitoring and observability becomes even more important. So we start to think about the challenges with implementing enterprise or observability at scale. So we're all here because we work in financial services or are thinking about how to leverage open source in finance. And there's a couple of challenges we want to specifically call out here. So first off, acquiring skills for implementing monitoring and observability solutions. This is a unique trait that you can't just expect every developer to understand and know. And operations teams are focused on this in addition to many other things. So having this specific skill set is something that could be a challenge in some cases. Application and infrastructure diversity. As I mentioned, we're all running across various infrastructure platforms, compute platforms, public and private cloud platforms. We're using various programming languages and frameworks, and those continue to evolve as we go over time. And taking all of these different application frameworks, languages, running all these various platforms and monitoring them in a unified single pane of glass way has always proven to be a challenge. So before we start to think about or solutions, I just want to quickly call out the steps of observability. So on the left, you have your telemetry. So this is how you're instrumenting your systems, how you're collecting your data, how you're transporting your data to some sort of platform that's going to give you it's going to store the data for you in an effective way. And we're talking about the key telemetry signals, metrics, logs, and traces. Those all involve different types of back-end storage platforms. You need to figure out how to analyze the data. You need to figure out how to alert on the data and get more real-time implementations so that you're not just eyes on glass looking for something to turn red. And you do need visualizations to help you get a better understanding of where there are potential problems in your systems. So this is where the enterprise observability tools come into play. I'm not going to mention any vendors. We're going to stay vendor agnostic in this session, but you can replace enterprise observability tools with whatever vendor you use for observability. So if we think about how we've solved observability at scale up to this point or up to within a few years ago within the industry, you really pick an observability provider or platform. You use their proprietary agents. They instrument your application at runtime, and then they handle all of the storage, analytics, and insights, generally powered by AI at this point. They provide you out-of-the-box alerting mechanisms, usually tied into your favorite chat provider or ticket management system, and they give you an easy way to visualize how to collect that data. So there's a lot of advantages to doing this, obviously. So you're using an out-of-the-box agent. It's really plug and play. You're getting that unified monitoring. A lot of these APM tools now are supporting all of the different infrastructure types, all the key public cloud providers. They support a wide variety of application frameworks and languages. They're giving you all of that analytics, alerting, dashboarding, visualizations that you need. They're handling all of the storage and scaling, which is generally a huge problem for all of our organizations as we think about how to do things at tremendous scale, which finance requires. And they're helping you with that AI-powered insights. So some of the disadvantages that we've obviously all come to love. These platforms cost money. They, in a lot of ways, require some operational setup with your core observability teams, especially in a regulated industry like finance. You have to work around the controls and regulations in order to implement these platforms. You got to teach someone a new tool, and every time you adopt a new vendor, you have to re-go through that whole process over and over again. And then feature set, I know I mentioned that the tools generally cover a wide variety of application languages and frameworks. They often do have gaps, and those gaps could be in their roadmap. They could have a specific framework that your organization is dependent on or starting to rely on more heavily, and that might not be in the roadmap till Q2, Q3, Q4 of next year, and you have no way to really drive that besides just escalation through their organization. And with all this, you're dependent on the vendor, right? So using their proprietary agents means that you're locked in. And that's something that could be scary for a lot of folks. So I'm going to hand it off to Vamsi. He's going to talk about what this might look like if you decided to use a purely open source observability solution or stack for your observability needs.
Hey, everyone. So just as Mike was showing in the previous slide, on the left side you have telemetry. First thing is you're on your own when you go to OpenTelemetry or open source solution, wherein you need to figure out what versions of the agents that you need to use, what your technology stack is, how you're going to correlate logs and traces and metrics, and what are different components of the OTel that you may be using, how you're going to package it with your application stack. That's all on you. On the right side, the observability platform of your choice, now you have to pick your own storage, how you're going to store them, what's the long-term strategy for the data that you're storing in the storage systems. And it's not only just the metrics, you have logs, traces, how you're going to scale it up, the dashboarding, the alerting, how they're going to interact with your the other systems as far as the alerting and the ticket creation systems that you have in your organization. But what are some of the advantages of using open source, specifically OTel here? Cost efficiency, you might save some costs on your agent licenses. You would definitely get community support based on our research. You could find a lot of community support and the groups that you can become part of and get some knowledge out of it and implement your target solutions at your firm or at your company. Easy integration. We find there are a lot of integrations possible with OTel, unlike a vendor-supported agent, where you have to wait for them to provide you that integration with. Innovation. As we all know in this room, there is a lot of innovation in the open source and in the OTel specifically. And finally, no vendor lock-in. Basically, by using an OTel agent, you can specifically point to any backend system where you're going to store your observability data. Regular updates. You'll find yourself if you're using a vendor agent of some kind, and if you need some kind of a new feature, you won't get these updates if you have to wait for months, probably and a year as well, based on the application stack that you're using at your company. Disadvantages of using open source or OTel. Support with vendor, you can call them, you can open a ticket, at least you get somebody on the phone to answer your question. Complexity. If you're not one of those popular languages that your application is using, or one of those popular stacks, then the complexity would be greater. However, there are some advantages of finding the solutions in the community. Scalability. It's not always scalable, particularly if you're not using one of these popular platforms.
So what if we were to try to take a blend of using open source technologies and enterprise observability solutions? So if we take ownership of our telemetry, which there's a lot of benefits of us being close to our data, being close to how our systems are instrumented. If we take back that ownership and instrument applications with OTel, but we continue to use enterprise observability tools that are going to handle a lot of the complexity around storage and scaling, dealing with the various metrics, log, and traces backends, doing the analytics and AI anomaly detection for you, giving you those alerting and visualizations out of the box. You get a solution that looks like this, where any of the enterprise observability platforms generally today are supporting OTel agents or OTel collectors for instrumentation. So you can now instrument your applications with OTel, and you can use the agents and collectors to send all of your data to any enterprise observability platform. Now, you get benefits from both of these solutions that extend beyond the benefits you would get if you just use one of them. And sure, there are still some disadvantages, but we feel like there's some advantages to a blended solution that are worth considering. So you get to take advantage of the enterprise observability platform's unified monitoring. You get to take advantage of the analytics, alerting, dashboarding, scalability, and the AI-powered insights. And from OpenTelemetry, you're taking advantage of the flexibility with your instrumentation, having developers more closely aligned to how their observability is built into their application and what are the key signals that they need for helping to better understand system health. You are still plugged into the community's support for OTel, which is a vast community, and you don't have to worry about all of those other tools that you would need to spin up as part of a holistic open source observability platform. So you would need a separate open source tool for metric storage, for log storage, for your traces, for visualizing all of those different data sources, for creating some sort of analytics around those platforms, for integrating with alerting. Those could all be additional open source platforms and tools that you would have to weave together in your organizations and create centralized support around in order for that solution to work holistically for everyone. So Vamsi's going to talk a little bit more about OpenTelemetry specifically, and then we'll wrap up.
So what are some things that we found out of our research? This is from 2023 from Open Source Forum, one of the links. There are about 450 plus companies contributing to OpenTelemetry projects. There are 30 plus vendors, commercial vendors support OpenTelemetry as the data source, which was the left side on the previous slides. There are 40K plus commits against OpenTelemetry projects. Just generally speaking, to give some context, if I pick to see how OpenTelemetry works, briefly, if I pick a Kubernetes platform or any container platform, which is kind of popular around in all the organizations these days, you would generally need the OTel to be integrated with your application, co-located with your application as an agent or a library. Depending on if it's a Kubernetes kind of workload, then you need to think about standing up a collector, which receives the data from these agents. You can further enrich what it received via processors, and there is an exporter component within the collector that would use OTLP export or something, and send the observability data back to your choice of backend data store. how do you reduce this complexity? Some of the things that you can think of is you can package these collectors and agents by using one of the IAC tools or configuration as code, particularly for the cloud workloads, to reduce the complexity. Generally, it's run as a daemon set if it's a container platform like Kubernetes. So this is to just say that it's possible using these methodologies how to reduce the complexity, part of the OTel. Secondly, you can make use of any code gen tools, such as any Gen AI tools these days. This is a sample showing a sample Java class. I asked a question to automatically generate a code for that particular for a simple class where it kind of generates a OTel code, a specific trace for a function within a Java function within my Java class. So you can use this kind of methodology to further automate and reduce the complexity.
So going back to those challenges that we talked about in the beginning, when introducing observability across large enterprises, Vamsi just kind of covered how we would go about solving that, acquiring those skills. AI can do a lot of that instrumentation for you as you're thinking about starting your OpenTelemetry journey. Gen AI, code gen tools have all of the knowledge and have been trained on all of the open source tooling. So because it's widely available on the internet. So those things become a lot easier for developers to do than they did even a year or 2 years ago. And auto instrumentation obviously helps with that as well. Going back 8 to 10 years ago, that didn't exist. So now you don't need to think about a lot of that complexity with OpenTelemetry, the auto instrumentation, and the ability to use generative AI to help you instrument functions that you need to outside of auto instrumentation will help solve a lot of the skilling challenges. Now, with application infrastructure diversity, OpenTelemetry includes everything that the enterprise observability platforms do generally from an instrumentation standpoint and more. We've seen that they generally support just as many frameworks and languages, if not more, than the enterprise tools do. And if they don't, you can contribute the necessary instrumentation and integrations to help the community. And lastly, creating unified observability, where we feel that there's using enterprise observability platforms still makes sense in a lot of ways in your organization. And some organizations might still choose to fully use enterprise observability platforms. Some organizations, generally we've seen probably smaller sized organizations go with a full open source stack. And here's just a possibility to blend the two to provide extra value for your organization. So just some food for thought, and with that, we'd like to open up the room for questions and discussion.
So it's an interesting problem. But generally, what we have seen from our research is that you generally package the collector along with your application stack. Instead of centralizing a collector for 100 Kubernetes instances so that you solve that problem in that way so that it would scale for that particular stack, right, for that particular instance. That's one way of thinking about it. We found again, it's a research thing, right? What we found is that when you package it with your application, you have more configuration choices. With the processors, you can eliminate the data that you don't need by setting up some rules. And you can also spawn different exporters per se. You can also make use of some kind of messaging system as well to offload some of these complexities of processing the data, sending the data to various backends, so on and so forth. And there is also a possibility that you can just, directly point your exporter configuration right back to your, whatever the backend that you may be using, or Prometheus or something.
The other, I think, thing to think about there is, should you be sending those metrics in the first place? And if there's a lot of metrics that you don't intend on ever making it to the observability platforms, why are you even asking your why are you even instrumenting that to begin with? So it really challenges the question and your development teams to really understand what they're instrumenting. And that goes back to the point of bringing in OpenTelemetry and having this be closer to home for developers will improve how the developers understand their applications and how they're supported in that DevOps lifecycle. So I'm going to just repeat it and just give me a nod if this is correct. So do we use a separate pipeline for Gen AI applications versus non-Gen AI applications? Specifically for log. Okay, so I don't know if there's generally a difference between Gen AI or non-Gen AI applications. We're using generative AI, or you can use generative AI across your entire application suite, and it's your code assist tool. That's what we're really talking about here. So as you're building an application, you can use your code assist, whatever tool you are integrating within your organization, to help you instrument your applications and write the code for you for any of your applications. There's no really separation between Gen AI or non-Gen AI applications. Sure.
Have you looked into using eBPF with OpenTelemetry?
So we are researching that, so that it gives us the profiles, method level hotspots. Yes, we are looking at it, right. Right. So with the vendor agents, that's a big feature. With Hotel, it's still evolving. So
Can do, I don't want to mention the name, but have you looked into it actively?
yes.
Can you share any, or it's NDA?
No, I mean, yeah, we can talk to you about what we've done. Yeah. Oh, okay. Do you want to repeat the question?
eBPF. The question is about eBPF, whether Hotel supports it, because it's a very good feature for an application developer to do end-to-end at code level, to find method hotspots, finding where in the code it's taking time, right, to execute. And Hotel, we saw a bunch of contributions in that space in the Hotel. We're also researching that. With some of the vendors, these come built in. If you remember one of the slides, on the left side, the agent, the proprietary agents, they provide these features out of the box, some of them. I'm not sure if it's true for everybody. So it's a big contribution that everybody is researching these days, wherein it makes the Hotel more valuable.
It was actually one of the enterprise observability platforms that contributed back the profiling to open source. So it just goes to show you that even the enterprise observability tools see where the open source community around OpenTelemetry is going, and they're contributing actively. And the fact that they support the Hotel OpenTelemetry standards and the metrics, logs and traces coming from Hotel collectors shows that even they're investing and see that there's room for growth in this space. Any other questions? Otherwise, I think we are.
Here's one more question.
Just a comment.
Yeah.
From JP as well. We're also contributing
Just to repeat that in case anyone's wondering, the comment was just about around, I believe, JP Morgan contributing to the Hotel collectors. So we're just about out of time. If anyone wants to connect with us in the hallway, please feel free. Thanks for coming.
Thank you.